Hello everyone. Today we are going to be continuing in section 6.2, which is on right triangle trig. And our focus of today are going to be using trig to solve application problems. So before we begin, we need to talk about a couple of vocabulary words that are used in these problems: angle of elevation and angle of depression. Um, Angle of elevation is pretty straightforward, and usually people don't make many mistakes with this. Imagine you are on flat ground and you're looking up. Let's say there's an airplane flying up ahead. So the angle of elevation is the angle along the horizontal that is created from your eyesight up to the object. And so this angle theta would be my angle of elevation from the person to the airplane. Now, angle of depression is the vocab term that people have the most issue with. So let's say you're in that same airplane and you spot a house down below. Now, the angle of depression is the angle that is made with the horizontal again, and you have the angle going down here to see the house. Now, the angle of depression is this angle here. It is not the angle that most people associate it with. It is the angle with the horizontal vision going straight out down to the object. Now, if you remember from parallel lines, if you think of, all right, these two lines are parallel, then these two angles here are congruent because they are alternate interior angles. So that angle we can then mark as theta as well. So in these problems, you're going to see these two words used throughout. Now, as we go through example problems here when we're doing e-learning, my suggestion would be to, after I read the problem, pause the video, draw a picture. Then unpause, see if your picture matches what I create. Then pause again and see if you can find the value that is missing. And then you continue on. It's going to be like a normal class, except it's going to be condensed into less than 15 minutes because there is not going to be that thinking time provided to you like I would in class. You've got to provide that with the pause button as you go through these videos. So first problem. From the top of the lighthouse, 210 feet high, the angle of depression to a boat is 27 degrees. Find the distance from the boat to the foot of the lighthouse. The lighthouse is built at sea level. So to draw our picture, we have our lighthouse. And we know the lighthouse is 210 feet tall. And then out in the distance, there is a boat. And so we know from the top of the lighthouse, our angle of depression, so if I draw my horizontal, the angle of depression is 27 degrees. And we want to know the distance from the boat to the foot of the lighthouse. So we'll mark that with X. And so now we could label the angle at the boat and the ground, that is 27 degrees. And now we can focus in on this right triangle. Now, with this triangle here, we're given the angle 27 degrees. We know the side that is opposite is 210, and we're trying to find the side that is adjacent. So, which trig ratio relates the opposite side to the adjacent side? That is tangent. So we know tangent of 27 degrees is equal to the opposite side, which is 210, over x, which means x is equal to 210 divided by tangent of 27 degrees, which comes out to be 412.148 feet. When you're doing this to the calculator, make sure that your calculator is in degrees and not radians. Now, a second way you could have done this problem is use the fact that you know these two angles at the top left have to add up to 90. So this is 63 degrees. And now I can do tangent of 63 degrees is equal to x over 210. So x is 210 times tangent of 63 degrees, which is also 412.148 feet. So either method would be fine for this problem. You have to choose what's best for you. Problem 2. To approach a runway of an airport in Chicago, a pilot must begin a descent of 3 degrees starting at a height of 28,000 feet above sea level. The airport is 550 feet above sea level. To the nearest tenth of a mile, how far from the runway along the ground is the airplane at the start to its approach to landing? So for this problem, we have our airplane up here at the top, and over here is our airport. Now, again, we have an angle of depression. Our angle that we're descending is 3 degrees. So I'm going to mark this. Obviously, it's much bigger than 3, but we can just go with that being 3 degrees. We want to find the distance along the ground from the airplane to the airport. Now, the tricky one here for the height is that the airport is 550 feet above sea level. The airplane is 28,000 feet above sea level. So the airplane is actually 27,450 feet above the ground that the airport is on. Again, the trig ratio we're going to deal with here is we have this is 3 degrees. This is the opposite side. This is adjacent for that angle. So this once again is tangent. So tangent of 3 degrees is equal to 27,450 over x. So x is 27,450 over tangent of 3 degrees, which comes out to be approximately 523,777.202 feet. Then we need to know, though, to the nearest tenth of a mile, how far that is. So there are 5,280 feet in a mile. So if I divide by 5,280, we get that it is 99.2 miles from the airport. Question 3. From the top of a building 50 feet high, the angles of elevation and depression to the top and bottom of another building are 19 and 26 degrees respectively. What is the height of and the distance to the second building? This is a tough picture to draw, so pause the video, try to draw it, and then once you have an attempt, press play and see how you did. So for this problem, we have a building that is 50 feet tall. So let's say this is that first building that we know the height is 50 feet. Now, there's another building nearby that is taller than the first building. And I know that because from that point, we have an angle of elevation is 19 degrees. So from that building, you look up at a 19-degree angle, you reach the top of that building. And if you look down at a 26-degree angle, you get the bottom of that building. And we want to figure out what is the height of the building. Well, hopefully you can see here we have two triangles. So I'm going to start first with this triangle on the bottom that is in blue. For this triangle, we have the angle is 26 degrees. We know that the distance has to be 50 feet from this point to the bottom. And we could then find the distance between the building, which I'm going to call x. So we can do tangent of 26 degrees is equal to 50 over x. So x is 50 over tangent of 26 degrees, which comes out to be approximately 102.515 feet. So that's how far apart they are. So that's the distance to the second building. Now, if I use this triangle on the top, we now know what x is. Now I want to figure out the value of y. So then I can add it to 50 to get the height of the building. So again, I can use tangent. Tangent of 19 degrees is equal to y over x. Now what I'm going to use for x, you can use the exact decimal. I don't want to use the rounded version. So I am going to go ahead and type in 50 over tangent of 26 degrees here, because that's exactly what x is. So y is 50 over tangent of 26 degrees times tangent of 19 degrees, and I get y to be approximately 35.299 feet, which means the height of the building is 85.299 feet. Problem 4. At 2.65 feet apart on the same side of a tree, and in line with it, the angles of elevation of the top of the tree are 21 and 16 degrees. Find the height of the tree. So again, a tough one to draw. Try to draw it. Pause. See what you get when you come back. All right, so this one, we have a tree. Here's our tree on the left side. We have the first time we look up at the tree, I'm going to call this point A. We look up, and then we move 65 feet away. We look up again, and we measure our angle of elevation. Well, the steeper the angle is going to be here at A, so that's the 21 degrees, which makes this the 16 degrees. We know this distance is 65. I'm going to call this x for the horizontal distance, and again, I'm going to call the height y. So we have two triangles here. The first one, I'm going to do in red. We have this right triangle here, which says tangent of 21 degrees is equal to y over x. And then we have a second right triangle here, where I have tangent of 16 degrees is equal to y over x plus 65. So we have a system of equations, two variables, two unknowns. I'm going to use substitution. I have here that y is equal to x times tangent of 21 degrees. And so I'm going to substitute that for y in the second equation. And now we need to solve for x. So I multiply both sides by x plus 65. And now I'm going to go ahead and distribute this. We've done some problems, equation solvings like this earlier in the year. So right now, solving equation when we get the x's on the same side, the constant in the other. So I am just going to take these two here and switch spots. So I have x tangent of 16 degrees minus x tangent of 21 degrees equals 65 tangent of 16 degrees. Now I can factor out an x. And divide. And so I get my exact answer. And it looks kind of sloppy. Sorry about that, but it's 65 tangent of 16 over tangent of 16 minus tangent of 21, which comes up to 191.914 feet. You then can take that, plug this in here for y, and you get y to be 73.669 feet. So try the problems tonight. Good luck, and we'll go over